So the last thing you need to know to be able to do this project is how to build simple plots in Python. So here's how you do it. It's actually very, very easy. Okay. So the first thing you got to do is you got to import the, well, I shouldn't say the, I should say one of the plotting libraries for Python. This is the one that most people use. It's called matplotlib. Okay. And it is very similar to what the plotting functions in, for example, R or in MATLAB. Okay, so that's where they come from. And you know, if you learn how to use this, you can actually use this in lots of other systems because they're all very similar. So here's what you need to do. You need to build a list of the x's and a corresponding list of the y's. So x's is range minus 5 to 6. So x's is going to look something like this. Starts at minus 5 and then it goes up to minus 6, okay? 2, 3, 4, and it stops at 5 because it doesn't go to the last endpoint. Okay, so that's what x's is going to have, and then you got to figure out what y's is. Well, y's will start at the empty list, and I'll write it like this. And then notice we hop in a loop for x in excess, right? So x starts out at minus 5, and then we append to y x squared. So y is going to have 25. Next up to the loop, x is minus 4, and we append to y's minus 4 squared, which is 16, right, and 9, and so on. And then 4, 9, 16, 25. So that's what the y's list is going to have. And then, I mean, this is it. PLT, notice I imported as PLT, so I don't have to call it matplotlib.pyplot. Right, just PLT dot. It's easier. So PLT.plot, right, that means create a plot. That easy. X's and Y's. And so it does that, right? Now, after that, it depends honestly on how you're running Python. If you're running Python in an interactive system, for example, it's loaded in your computer and you're using one of the integrated development environments like Canopy or Anaconda, you can actually type plt.show. And if you type that, the graph will just magically appear on your monitor and you can look at it. Okay, that's the easiest way to do it. In our environment that we're using, we're running Python through the web browser, so it's running on a server that's someplace else. It can't make the graph pop up on your computer. Okay, so instead what we'll do is we'll save it. And plt.savefig actually saves it in a graphics format to the disk. And in this case, we say fig x squared.png, so it's going to save it as a PNG file. That's a portable network graphics, which is one of the standard formats on the internet. You probably have seen lots of PNG files just surfing the web. Okay, so here is the file that actually got generated. Okay, and if you're in REPL.it, okay, when you hit run, it will actually create that file, and REPL's documentation says that the file will then be displayed. I've never had that happen. So just look in the tab where where you're coding, where you're programming, where your program is, and you'll see there's a little tab that has the name of your program, and a new tab is going to show up that has the name of the PNG file. Click on that, and you'll be able to see your graph. Okay, so there we go. That's our first graph. Now, one thing I don't like about that graph, and you should develop this kind of aesthetic, okay, that if I show you that graph, you wouldn't have any idea what it was, right? You don't want to surprise your readers. You want them to be able to tell immediately what it is. So let's add a title. Oops, sorry about that. I forget to keep putting this in pen mode. But let's add a title, graph of x squared. That way, if you give that to me, I can look at it and go, oh, I know what this is, okay? So right here, this axis is just the x's. This axis is the y-axis, which has y equal x squared. Now I know what this is, okay? So how do I add those? This is very similar to the old program. The stuff that's new is right here. Okay, so the first thing we do is we say plt.xlabel, label the x-axis, and we give it a string. I want it to be x. plt.ylabel, label the y-axis. I want that to be y equals x squared. And then plt.title, I want something to appear at the top. That's graph of x squared. And just as before, we save it. Nothing else changed. It was just those three things. Always do those three things, okay? In fact, when I start doing a graph in Python, because it's easy for me to forget, you know, exactly what is it called, X label, X title, I don't know. So what I do is I just go to a previous place where I did this, and I copy and paste that code and then change the names of the graphs and so on. So I don't start from scratch. I start from something that looks kind of like this, okay? All right, now that's great. But what I want you to do is to build a graph that has, and let's see, the graph might look like this. This is the number of primes. Now remember, it can't be growing very fast because, well, at most half the numbers are prime, right? So it has to be growing something like that. Notice that it's getting shallower as n gets bigger. Oh, I should have n here, number of primes there, right? Something like that, right? Now, on top of that, I would also like to put, oh, bummer. I was hoping to change color. New system, things don't work the way they used to. But anyway, we want to have some different graphs here that you can compare to, right? So for example, I might compare to a graph that looks like that. I might compare it to another one that looks like this, okay? And so on. And just to try to get a feel for which one it is. And there may be another one that's really, really, really close, right? So it might look like that, okay? And I'd like to have some sort of a legend so that I can tell what all of these are. So this might be n primes, right? This might be y equals x squared, and so on, right? I want to explain what those different graphs are. And that way I can say, oh, definitely the one that looks like the pluses, that's the one that's most like number of primes. That's what you're doing for this project. So how can you do that? Actually, what you do is you create a list of x's, just like you did before, and then you create multiple lists of y's. So here's y2 and y3, right? So y2, you can see, is x squared. y3 is x cubed divided by 5. You're going to have your own functions for what those should be. And then you have two different plots, right? This one plots x's versus y2. This one plots x's versus y3, right? So the blue one here is the first one. That's the x's versus y's too. Notice it has a label equals. Remember functions and how we can add optional parameters? Here's a parameter that you normally don't need, but sometimes it's really important. Like here, I want to make this line different than the line that's coming. This one is called x squared. The next one says label equals x cubed over 5. Again, we just achieved giving it a name. And that information is showing up here. Okay. Now, the reason it's showing up here is because we did this. We call plt.legend, right? This is called a legend. It tells you what each one of the colors or line types is. And we want it to be in the upper right. I could have made it in the middle, right? I could have put it in the upper left, the lower right. You can decide where you want it, okay? That's the only difference between this graph and previous graphs. So this is how you're going to build a graph that you're going to turn into me. All right, good luck. You know everything you need to build Project 2, so have at it.